Hey everyone, and welcome to the Explainer. Today, we are basically doing an unboxing, but instead of the latest gadget, we are unpacking a massive, highly anticipated research paper straight out of NVIDIA. It's called Cosmos 3, Omnimodal World Models for Physical AI. Look, if you've been tracking the breakneck speed of AI development, you know that the holy grail right now is bridging the gap between digital brains and our messy, actual physical world. This paper outlines a highly structured approach to conquering exactly that frontier. We're going to break down what Cosmos 3 actually is, look under the hood to see how it works, and talk about why this specific architecture is making such huge waves in the research community.
Okay, let's dive into this and quickly map out where we're headed today. First, we'll meet Cosmos 3. Then we'll unpack its unified architecture, check out its record-breaking results, go over the details of its open-source release, and finally zoom out to look at the future of physical AI.
All right, let's kick things off with Section 1, Meet Cosmos 3, Unboxing the Concept.
So what exactly are we dealing with here? Cosmos 3 is an omnimodal model. Now, you might be familiar with multimodal models, the ones that handle text and maybe some images, but Omnimodal takes it to a whole new level. It means the system jointly processes and generates language, image, video, audio, and, this is the real kicker, action sequences for physical AI. It's not just passively observing its environment, it's actively mapping out how to behave within it. Grasping this omnimodal definition is absolutely crucial, because it represents a system trying to simultaneously capture the entire spectrum of how a physical environment actually operates.
Building something that comprehensive is, well, it's a monumental task. 294. That is the staggering number of authors and researchers at NVIDIA who collaborated to submit this paper back in June 2026. Just think about that for a second. Having 294 highly specialized minds working in perfect sync to push the boundaries of physical AI really gives you a sense of the immense scale and the profound technical difficulty of this project.
Moving right along to Section 2, the unified architecture, the Swiss Army knife of AI.
Cosmos 3 essentially acts like a Swiss Army knife for artificial intelligence. It supports highly flexible input and output configurations across all these modalities natively and at the exact same time. We're talking language, image, video, audio, and action sequences. Imagine being able to prompt a model with a short video clip and some ambient audio, and having it instantly generate a logical physical action sequence in response. Processing all of these dynamic streams simultaneously requires highly optimized encoders, which completely changes how the underlying infrastructure has to be built.
And that brings us to the shift from the old paradigm to the new Cosmos 3 framework. In the past, researchers were basically duct taping together separate vision language models, video generators, and action simulators. It was fragmented and frankly pretty inefficient. To consolidate all of this into a single, seamlessly unified framework, NVIDIA had to pioneer some massive infrastructure upgrades. We're talking vastly optimized data processing, huge storage solutions, and advanced distributed training optimizations. They basically put this system through a massive scale pipeline with incredibly precise pre-training, mid-training, and post-training phases.
So, what is the actual engine under the hood making all of this work? It is a unified mixture of transformers, or MOT architecture. To handle all those diverse real-world inputs we just talked about, this MOT architecture uses autoregressive, or AR, reasoning towers working right alongside diffusion model, or DM generation towers. It then translates the real world into data using highly specialized encoders. Specifically, it uses a VIT for images, a video VA for motion, an audio VA for sound, and a unified action encoder for physical movement. It's honestly a brilliant way to build a singular architectural brain that can process multiple chaotic streams of reality.
Let's see how it actually performs. Section 3. Record-breaking benchmark results. Checking the specs.
Right in the abstract of the paper, the authors state that, quote, Cosmos 3 establishes a new state-of-the-art across a diverse suite of understanding and generation tasks. And they really did put this thing through the ringer. They didn't just optimize for one narrow trick. They tested both its ability to comprehend incredibly complex inputs and its ability to generate top-tier outputs.
For instance, an independent evaluation by Artificial Analysis ranked the post-trained Cosmos 3 models as the absolute #1 open-source text-to-image and image-to-video models. This dual victory is huge, guys. Achieving this level of visual generation quality while also functioning as a general-purpose model that handles things like audio and physical action is incredibly rare. It's literally beating highly specialized, dedicated media models at their own game.
But remember, the ultimate goal here is physical AI, right? Acting in the real world. Well, at the time of the technical report, Cosmos 3 was also ranked as the #1 policy model by RoboArena.
In this context, a policy model is basically the system's ability to make logical decisions and determine the right sequence of actions for an embodied agent, like a robot. Winning this specific benchmark proves that Cosmos 3 isn't just a fancy media generator, it is a highly capable, logical brain that is ready to pilot physical machines.
Which brings us to the really exciting part for the builders out there. Section 4, the open source release, availability, and access.
NVIDIA is treating this release like a massive accelerator for global open research. They aren't holding back. The release includes the underlying code, the actual model checkpoints, which is huge because it means the massive computational heavy lifting of training is already done for you, as well as their curated synthetic datasets. And crucially, they're releasing their comprehensive evaluation benchmark known as Cosmos Hue. By giving away Cosmos Hue alongside the datasets and code, researchers everywhere have exactly what they need to study, reproduce, and build on top of NVIDIA's foundational work.
And for the developers tuning in, you'll be happy to know the paper clarifies this release is governed by the Linux Foundation's Open MDW 1.1 license. Having a clear, standardized licensing framework is absolutely vital. It ensures the open source community can confidently integrate and innovate on these models without worrying about legal ambiguities slowing down their progress.
So where can you get it? The materials are available right now on the two biggest hubs for AI development. You can grab the repositories on GitHub under NVIDIA/Cosmos, and you can find the actual models over on Hugging Face at NVIDIA/Cosmos 3. Basically, the barrier to entry for experimenting with state-of-the-art physical AI has just been completely demolished.
Let's wrap things up with Section 5, the future of physical AI, the big picture.
If you take one thing away from this explainer, make it this. Cosmos 3 serves as a scalable, general-purpose backbone for future embodied agents. This isn't just another neat software tool. It's designed to be the foundational brain for physical robots. Because its mixture of Transformers architecture so deeply understands how video, audio, language, and physical actions are all intertwined, it can be deployed into robotic hardware to help those machines navigate, understand, and safely interact with our chaotic real world. It scales smoothly from digital simulation directly into physical reality.
So I want to leave you with a provocative question to chew on. How will unified open source models like Cosmos 3 change the physical robots we interact with over the next decade? Now that developers worldwide can just download a state-of-the-art brain capable of understanding sights, sounds, and physical actions all at once, the pace of robotic innovation is bound to absolutely explode. If you want to dive deeper into the technical specs we covered today, the paper directs readers to the NVIDIA Cosmos Lab project website. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.